Every machine tool company in this history eventually made something you could point to: an engine, a milling machine, a caliper you could hold in your hand and read a measurement off of. The company at the center of this story made something almost nobody ever thinks about at all: the screw. Not a famous screw, not a patented screw, just an ordinary, identical, endlessly repeated piece of threaded steel. The kind holding together every appliance, every automobile, every rifle assembled in the United States for most of the 20th century. According to the company's own corporate history, during the Second World War, more than 90% of every rifle and machine gun bullet core produced for the American and Canadian militaries. The plain steel slug inside every .30 caliber and .50 caliber round fired by the Allies was made on this one company's machines. And yet, almost nobody outside the trade has ever heard its name. By the mid-1990s, the corporation that had quietly built the backbone of American mass production had been dismantled into 3 separate pieces, sold off to 3 different buyers in 3 consecutive years, and the Cleveland factory floors that had once turned out that 90% of the Allied war effort's ammunition components went dark for good. This is the story of National Acme and Cleveland Twist Drill, 2 companies that spent most of the 20th century making the machines nobody noticed and the tools that cut them, until a merger built to make them stronger instead made them easier to take apart, piece by piece, inside a single remarkably short decade at the very end of their shared existence. The story actually starts as 2 separate companies, born a couple of decades apart, that would not meet for most of a century. The older of the 2 began in 1875, when a young Clevelander named Jacob D. Cox borrowed $2,000 from his father to buy a 50% stake in a small twist drill shop in Dunkirk, New York, run by a machinist named C.C. Newton. Cox came from a notable Ohio family. His own father, a Civil War major general and former governor of the state. But the son had chosen to make his own way in the iron and tool trade rather than in politics, spending years learning the business in Cleveland's own rolling mills and furnace works before making the move into Newton's small operation. Within a year of buying in, Cox convinced Newton to relocate the whole business to Cleveland itself, arriving there in September 1876, betting that a growing Great Lakes port city with deep connections to the region's steel industry would serve the fledgling drill company better than a small town in western New York ever could. The partnership did not survive contact with reality for long. It split apart after 4 difficult years, leaving Cox holding Newton's stake and $9,000 in debt for his trouble. He brought in a nephew, Frank F. Prentice, who took a 40% share of the business and became its salesman, while Cox himself focused on the actual design and manufacture of drills and cutting tools. The firm, now called Cox and Prentice, struggled hard enough in its first decade that by 1886, Cox tried to sell the whole operation for $75,000 and found no buyers. He kept it instead. The business slowly turned around, and by 1888, the firm, renamed the Cleveland Twist Drill Company, had outgrown its original quarters and moved to a larger plant at Lakeside and East 49th Street, the location that would anchor the company for the next 100 years. Cleveland Twist Drill incorporated formally in 1904, and the following year, Jacob Cox, the founder, retired, handing the presidency to his nephew and partner, Frank Prentice, a more optimistic and expansion-minded leader than the cautious founder had been. Cox, restless in retirement, rejoined the company as president again in 1910 and stayed until 1919, when he moved up to chairman, remaining an active presence at the firm until his death in 1930. His son, Jacob Cox Jr., a Williams College graduate and Phi Beta Kappa member, who had started as an ordinary mechanic on the Cleveland Twist drill shop floor after a stint working for a logging company in British Columbia, took over the presidency in 1919 and ran the company for more than 3 decades. He turned out to have an unusual set of priorities for an industrial executive of his era. Priorities he later wrote about at length in a book called The Economic Basis of Fair Wages. He introduced an employee profit-sharing plan, paid vacation time, group life insurance, a sickness and accident fund, retirement pensions, and a policy of hiring disabled workers wherever possible. And by most accounts, the company never experienced a work stoppage due to a labor dispute during his entire tenure running it. A genuinely unusual record for a Cleveland manufacturer across the labor turbulence of the 1930s and 1940s. Under his leadership, the company's research department made its single most important technical breakthrough, the patenting of a high-speed tool steel the company branded Momax, made from molybdenum and tungsten rather than tungsten alone. Cutting tools of that era needed a steel hard enough and heat-resistant enough to keep a sharp edge while cutting other metal at high speed, and tungsten had long been the standard alloying element for that job. But tungsten was expensive and, at various points, difficult to source reliably. Momax let Cleveland Twist Drill make tools of comparable performance, using a much larger proportion of molybdenum, a cheaper and more readily available metal, a substitution that cut the company's material costs and insulated it from tungsten supply shortages, just as the country moved through the Depression and toward the Second World War. By 1936, Cleveland Twist Drill had become, by most contemporary accounts, the world's largest maker of high-speed drills and reamers, a title it would hold for years afterward. The twist drill itself is worth pausing on, because it is one of those tools so completely ordinary today that it is easy to forget it had to be invented and refined at all. A drill bit's defining feature is the pair of helical flutes spiraling up its body, and those flutes are not decorative. As the cutting edges at the tip shear metal away from the bottom of a hole, that waste material, the chip, has to go somewhere, and if it cannot escape, it packs into the hole, generates friction and heat, and can snap the drill outright. The helical flute acts like a continuously turning screw conveyor, carrying chips up and out of the hole as the bit rotates and advances, which is also why a drill bit run at the wrong speed or fed too aggressively tends to fail by clogging rather than by simple dullness. Getting that helix angle right, along with the exact geometry of the cutting lips at the tip, was the difference between a drill that lasted for a few dozen holes and one that lasted for thousands. And it was precisely the kind of incremental, unglamorous engineering problem that Cleveland Twist Drill spent decades quietly perfecting, while other, flashier companies built the machines that got the historical credit. While Cleveland Twist Drill was building its reputation on cutting tools, the second half of this story was unfolding 2 states away in Hartford, Connecticut, where 2 mechanics named Edwin C. Henn and Reinhold Hake-Wessel spent more than a decade working through what a later company history politely called great difficulties, trying to perfect a genuinely new kind of machine. Neither man came from money or connections. They were working machinists, trying to solve a manufacturing problem on their own time, in an era when that kind of self-directed invention was still the normal route into the machine tool trade rather than the exception. What they eventually built and patented in 1894 was a multiple spindle automatic lathe, a machine built to solve a problem every hardware manufacturer in the country had, making an enormous volume of small, identical, threaded parts, screws above all, without a machinist standing over a single lathe, turning them out one at a time. A friend put up the money to found the Acme Screw Machine Company in Hartford in 1895 to build it, but the business nearly failed within 2 years. The same story of undercapitalized ambition that would repeat itself at nearly every machine tool startup of this era, from Providence to Springfield to Bridgeport. Desperate, Henn sent his brother A.W. to Cleveland to hunt for an investor, and that trip produced the deal that saved the company. Henn traded 25 Acme machines for cash and a 50% stake in a Cleveland manufacturer called the National Manufacturing Company, a firm that had itself been using Acme machines to make its own parts and understood exactly what the technology was worth. In 1901, The two firms formally merged into the WWII, National Acme Manufacturing Company, based at 7500 Stanton Avenue. And by 1914, it had become one of Cleveland's largest employers in its own right. To understand why that multiple spindle automatic lathe mattered enough to build an entire industrial company around it, it helps to understand exactly what problem it solved. An ordinary lathe, even a well-run one, holds one piece of bar stock and cuts it with one tool, moving through one operation at a time. Turn a diameter, cut a thread, face an end, part off the finished piece, one step after another, on one part at a time. Hen and Hank Wessel's machine took that entire sequence and multiplied it. Their design mounted several spindles, typically 6 or 8, arranged in a circle around a rotating carrier, with a separate bar of raw steel stock feeding through each one. Around that circle sat a ring of fixed tooling stations, each one performing a single specific operation: facing, turning, drilling, threading, cutting off the finished part, and all of it choreographed by a set of rotating drum cams that controlled exactly how far and how fast each tool slide moved at every point in the cycle. The critical trick was this: every spindle sat at a different station, doing a different operation at the very same moment. And when the whole carrier indexed forward to the next position, each spindle's workpiece moved one step further along its own sequence of operations, while a brand new, fully finished part dropped out of whichever station happened to be doing the final cutoff. A single spindle lathe finishes one part per complete cycle. A 6 or 8 spindle Acme machine finishes one part on every single index of the carrier, which meant its effective output was multiplied by roughly the number of spindles running, all from one machine, one operator, and one motor. It was, in effect, an entire small assembly line folded into a single rotating drum of steel, and it was exactly the machine and economy filling up with mass-produced hardware, appliances, bicycles, and eventually automobiles needed in enormous numbers. National Acme kept building on that foundation. In 1915, the company acquired the Windsor Manufacturing Company of Vermont, a maker of its own competing multiple spindle automatic machines designed by an engineer named George Gridley, and the combined product line became known industry-wide as the Acme Gridley, a name that machinists would still be using on second-hand machine listings a century later. Buying out a direct competitor, rather than simply racing against it in the marketplace, was a deliberate strategy, and it paid off almost immediately. The timing was excellent. World War I sent demand for multiple spindle automatics soaring, as arsenals on both sides of the Atlantic needed exactly the kind of high-volume, interchangeable small parts production those machines were built for. Artillery fuse components, small hardware, and eventually ammunition parts among them. And National Acme expanded its plant capacity to keep up, eventually breaking ground on an entirely new facility at East 131st Street and Coit Road. Designed by the Rhode Island-born industrial architect, George Smith Ryder, a man responsible for a considerable share of the industrial architecture that came to define Cleveland's manufacturing districts in this era, and completed around 1916. With that new plant running, the company made a deliberate strategic choice that would define its identity for the rest of its existence. It got out of the business of manufacturing and selling the actual screws and fasteners its machines could produce, deciding that competing with its own customers for that business made less sense than simply selling everyone the machine, and concentrated entirely on selling the machines themselves to other manufacturers, formally incorporating under the simplified name National Acme Company in 1916. The war's end exposed exactly how dangerous that kind of concentrated wartime growth could be. When Allied government orders stopped almost overnight in 1918, National Acme was left overstocked, overcapacity, and undercapitalized. Its new plant and expanded workforce built for a level of demand that simply vanished the moment the armistice was signed. A lesson the company's management would remember and apply rather differently when the next war came. The Great Depression that followed a decade later nearly finished the job the post-war collapse had started, squeezing the company from the other direction as industrial capital spending across the country simply stopped, and machine tool orders, always among the first casualties of a recession, because a factory can defer buying new equipment far longer than it can defer paying its workers, dried up almost completely. National Acme survived it, in large part by having already learned, the hard way, not to overextend itself, chasing a single wartime demand spike a second time. Both companies survived, and both were tested again within a few years by a demand shock even larger than the first war had produced. This time, with the added benefit of hard-won institutional memory about what happens when a wartime boom ends. When the United States geared up for the Second World War, Cleveland Twist Drill and National Acme were both awarded the Army-Navy E Award, the highest recognition the federal government gave to a civilian contractor for excellence in wartime production, in a pair of ceremonies held on the same day, May 23, 1942, presided over by Undersecretary of the Navy James Furich Forrestal and Captain E.B. Almy, the Navy's coordinator of machine tools, with the company's own production workers represented at the podium by Michael Bazovsky, president of the local mechanics union. The scale of what National Acme's machines actually did during the war is, by the company's own later account, almost hard to believe. More than 90% of all 30 and 50 caliber bullet cores manufactured for the American and Canadian militaries came off Acme Gridley multiple spindle machines, meaning that the overwhelming majority of the actual lead and steel cores, riding inside Allied rifle and machine gun ammunition, fired everywhere from the beaches of Normandy to the islands of the Pacific, had been shaped by a Cleveland-built machine, descended from two mechanics' patent out of Hartford, Connecticut. The 2 decades after the war were, on the surface, comfortable ones for both companies. Cleveland's broader machine tool industry stayed healthy through the 1950s, even if its boom years were technically already behind it, and the city's 1954 census placed machinery production second among its leading industries in both employment and total value of goods produced. Both firms kept growing largely through acquisition rather than dramatic invention during this stretch. Cleveland Twist Drill picked up the Bay State Tap and Die Company of Massachusetts and the Eastern Machine Screw Company of Connecticut, expanded its manufacturing into Canada and the Netherlands, and established a Scottish subsidiary, while National Acme added Shalco Systems, a 6-year-old California maker of foundry shell and core mold machines vital to producing heavy parts like automotive engine blocks and heads, in 1959. Both companies, in other words, were doing exactly what larger established machine tool builders across Cleveland and the rest of the country were doing at the time, using acquisitions to smooth out the notoriously narrow profit margins of the machine tool trade by simply running more volume through their existing plants. The two firms, still entirely separate at this point, despite sharing a city and increasingly a customer base for nearly 60 years, finally came together on October 25, 1968, merging into a single corporation called Acme Cleveland, with Cleveland Twist Drill's own president, Arthur Armstrong, chosen to lead the combined firm. The new company's interests now spanned machine tools, foundry equipment, and electrical controls, serving the automotive, capital equipment, and screw machine products industries all at once. And it kept acquiring through the 1970s, adding LaSalle Machine Tool in 1972, a 36-year-old builder of automated production systems for internal combustion engine parts that represented, at the time, the leading edge of what the industry called total manufacturing systems. By 1980, Acme Cleveland was one of the largest machine tool manufacturers in the United States, with sales crossing $400 million in both 1980 and 1981, and a workforce of 6,300 people spread across its Cleveland plants and the various subsidiaries it had absorbed along the way. Then, Within 2 years of that peak, the wheels came off. A recession, an aggressive wave of Japanese competition in exactly the mid-sized, general-purpose machine tool categories Acme Cleveland depended on most, and what more than one contemporary account bluntly called corporate inefficiencies combined to produce a loss of nearly $32 million in 1983 alone. A staggering reversal for a company that had been posting record sales just 2 years earlier. The pattern was one that would have been painfully familiar to Cleveland Twist Drill's own founder a century earlier. A machine tool builder that had scaled up hard to meet peak demand suddenly found that demand evaporating. Only this time, the threat was not a war ending, but an entire category of competitively priced, increasingly capable imported machinery arriving from Japan faster than American builders could respond to it. A costly lawsuit made things worse. The company's LaSalle machine tool subsidiary had signed a 1983 contract with Vickers to deliver a fully automated flexible manufacturing system, and, according to the resulting litigation, failed to deliver on it. A dispute that went through federal court, an appeal, and finally a settlement in which Acme Cleveland paid Vickers $4 million in cash, plus another $4.5 million in machine tools. Acme Cleveland spent the entire decade from 1982 to 1992 losing money, a cumulative $45.5 million more than it earned, while sales collapsed from nearly $500 million down to just under $113 million, and the workforce that had stood at 6,300 people in 1980 was cut to roughly 2,000 by 1993, a reduction of almost 70% inside little more than a decade. Management's answer was not to double down on machine tools, it was to leave them behind. Starting in 1984 with the acquisition of Communications Technology Corporation, a maker of equipment for the regional Bell telephone operating companies, Acme Cleveland began deliberately building what it called its emerging technology growth businesses, adding a network access equipment maker called T-Export in 1994, and building up subsidiaries like Namco Controls, an electronic sensor manufacturer, and M&M Precision Systems, a precision measurement instrument maker, none of which had anything to do with cutting screws or drilling holes. By the early 1990s, notably, the strategy appeared to be working on paper. The company recorded its third consecutive profitable fiscal year in 1990 and was named Turnaround of the Year by the Turnaround Management Association in 1991, a recognition that, in hindsight, marked not the rescue of a machine tool company, but the final stage of its conversion into something else entirely. The final act arrived in 3 sharp consecutive strokes. In 1994, Acme Cleveland sold the Cleveland Twist Drill Company. The firm Jacob Cox had started with a $2,000 loan more than a century earlier to Greenfield Industries, a cutting tool manufacturer that folded the name into its own product catalog. The following year, 1995, the National Acme subsidiary, the machine that had shaped more than 90% of a world war's worth of ammunition, was sold to WWII Bullard, a larger holding company that collected machine tool brands the way other conglomerates collected real estate. And in the middle of 1996, Acme Cleveland itself, the parent corporation, now built almost entirely around telecommunications equipment and electronic sensors, rather than machine tools, was acquired by the Danaher Corporation, a diversified industrial conglomerate based in Washington, D.C., for roughly $200 million. 3 buyers, 3 separate transactions, 3 consecutive years, and a single Cleveland company that had taken 67 years to merge itself together came apart in barely 24 months. The Cleveland Twist Drill plant on East 49th Street was shut down for good not long after the sale. The National Acme works at East 131st and Coit Road. The plant George Smith Ryder had designed to arm 2 world wars sat abandoned for years afterward. Its cavernous machining bays eventually stripped and left to decay, one of the countless empty industrial husks that came to define large stretches of Rust Belt Cleveland by the end of the century. There is a particular kind of irony in how completely this company disappeared from public memory relative to what it actually built. Nobody names a car after National Acme. No museum wing is devoted to the multiple spindle automatic lathe the way one might be devoted to a famous locomotive or an aircraft engine. And outside of secondhand machinery dealers and the machinists who still run Acme Gridleys on job shop floors today, the name means nothing at all to most people, even people who work in manufacturing. And yet for the better part of a century, an enormous share of the ordinary manufactured world, the screws holding a nation's appliances and automobiles together, the drills and reamers cutting the holes those screws threaded into, the bullet cores fired by 2 Allied militaries across 2 continents in the Second World War, pass-through machines built in these two Cleveland factories. Jacob Cox borrowed $2,000 to buy half of a failing drill shop in 1875. Two mechanics in Hartford spent a decade perfecting a lathe nobody had asked for. Both bets paid off almost unimaginably well, arming two world wars and quietly automating the small, unglamorous parts every other industry depended on, without ever needing to notice. The company that quietly automated the making of the world's smallest, most forgettable parts ended up, fittingly enough, as one of American industry's most forgettable names, dismantled into 3 unrelated corporate portfolios within 2 years, and left with no factory, no brand, and almost no one left to remember that it had ever mattered at all.